This is Fan of Astronomy, Episode 3.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
We are back yet another time. Hopefully people are listening to this. I am the host, Angelo, and my other host here is the Swedish superstar himself, Dan.
Hi, Angelo.
How are you today, sir?
I am extremely good. How are you?
I'm extremely tired.
Oh, how so?
Well, I mean, it's 1:45 where I'm at. So we can start there. And I've been working a lot lately, so that just happens.
Yeah, it's, I would not be able to podcast at 1 a.m. at night.
Well, luckily for you, I'm an insomniac, so.
Good.
But, you know, hey, we do ask that you guys do some Patreon stuff for us. The reason we ask this is because, look, we're putting in a lot of research, and realistically, this is a small cost for a lot of big content. We're asking that you donate $2 per episode. This is $4 a month, less than lunch. And we have bonus stuff for you. Dan, what is that?
Yeah, if we can hit $100 on Patreon, we're gonna do a bonus episode about how the universe is trying to kill us.
That'll cheer your day right up, won't it? Anyway.
Cheerful content from Fan of Astronomy.
Absolutely. And what we'll do is every $100 mark, we'll come up with another special episode, and we will throw a special episode at you guys for every $100 mark we hit, up into 700, I believe.
Yeah, where we will go weekly.
Yep, which will be more
These
work.
bonus episodes will appear on the week we don't have a regular episode, but once at 700 you get regular episodes every week.
Yes, lots of extra work, but at that point it'll be financially reasonable for us to put in all that extra work, you know, so.
I would love to cast about astronomy every week.
So would I. We could get through a lot more stuff. We wouldn't spend an entire year going over our solar system, which is probably...
That sounds boring.
Well, it's probably what's going to happen.
Yeah, it probably is, because there's a lot to say about the solar system.
So, patrons, become one.
Do
And
it.
yes, do it. You know you want more. You want to hear Dan's voice every week.
Of course you do.
Of course you do. I don't know if I want to hear his voice every week, but hey, you can make me hear his voice every week by just becoming a patron and donating. So, our topic for today is good old first planet from the sun, Mercury, which is a astonishing 0.38 AUs from the sun. It is our innermost planet.
That's pretty far from the sun, actually. It's much closer than the Earth, of course. But if you look at other solar systems, most of them may be based on the bias of discovery, but most of them have stuff closer to their star, even with stars as big as the sun. So you get the hot Jupiters, the gas giants hugging their star, and you also get smaller terrestrial planets close to the stars, but we don't have that. And we didn't like this very much, so we have spent hundreds of years trying to look for something closer to the sun than Mercury. Because Mercury, from the Earth, Mercury is extremely close to the sun, and it's hard to see. You can only see Mercury very early in the morning or very late in the evening. So originally we thought it was two different objects, but then we spent hundreds of years trying to look for something closer, and even got a name, and you might recognize the name if you're a Star Trek fan. Are you a Star Trek fan, Angelo?
A little bit.
Yeah, so it was called Vulcan.
Okay.
Vulcan. Yeah.
That one I do recognize. Like, it's certain series, like Next Generation, I'm a big fan of. The original, I like it, but I'm not like a crazy, you know, Star Trek original fan. And like DS9 was horrendous to me. And Voyager was even worse. So, yeah, I like the movies too, so.
Yeah, but if Mr. Spock would have been hanging around on this planet inside of Mercury, he would have been fried. But there is nothing there. There is almost no asteroids or anything, because once you get past Mercury, you enter the gravitational well of the sun, and it's very, very hard to have a stable orbit. Yeah.
I was going to say, it's actually, when you think about it, it's only a little bit over halfway between Earth and the sun.
True.
So it's not that far away, to be real honest, on a cosmic scale. And to think that there's another planet in there, So like the first few planets are really close to each other.
It's kind of crowded. Randomly, the distance to Mercury from Earth is about the same as the distance to Mars.
Yep. And just think, between Earth and Mars, stick another planet, and that's really close.
That's really close.
So, and we'll be talking about that other planet in the next episode. So, maybe you might want to send us a question about it. Ha. I just needed to throw that in there.
That is a very much more interesting planet than this one.
Well, yes. Yeah, there's a lot of neat things going on with that planet, like just its spin. But anyway, Mercury is our smallest of all the planets. It has a diameter of only 4,880 kilometers.
Yeah, and that makes it smaller than two of the moons in the solar system. So Ganymede of Jupiter and Titan of Saturn is actually bigger volume-wise than Mercury, but they're not heavier because Mercury is really, really heavy.
Very heavy. 5.4 grams per cubic centimeter. That's the second most dense planet, only behind us.
And that confused me quite a bit for a long time because Mercury is almost, it's metal. It should be denser than the Earth, but the Earth is so massive that the Earth pushes itself, it sort of crushes itself with its weight. So that makes the Earth more dense, but it was kind of hard to grasp why the Earth is more dense than Mercury.
Yeah, at that point you're getting into almost thermodynamics, where you're taking pressures, and the pressures is what's changing everything.
Yep.
So, pressure means something. Hey, how about that?
Amazing.
Woohoo! So, Mercury, for those who don't know, is named after a Roman god. It was also known as the messenger to the gods, but he was the Roman god of commerce, travel, and of course thievery.
Yeah, Hermes in Greek mythology.
Yes, it was known as Hermes in Greek, but we don't care about the Greeks. We only care about the Romans.
But Hermes is interesting because you have these amazing Hermes dick statues.
Yeah, but the Romans were cooler.
Yeah.
They ruled for a long time. Anyway, it got the name because of the speed it moved in the sky. It's often referred to as the traveler. So,
as this is one of the few objects you can actually see without a telescope, it has been seen for a long time.
It is a very, 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 very long time. Like how long?
Well, since the first person looked up, pretty much.
Pretty much. We don't know who discovered this thing. It's that old and we've known it for that long, but the first record...
I think it was Uga Uga, the Australopithecus.
Uga Uga, the Australopithecus, yes.
Yeah, I give credit to him.
You sure it wasn't Harambe? I mean, let's just give everything to Harambe, right?
Okay, let's do it.
I can't believe I said that.
The sources are bad.
They are. But the first record that we actually have of it is from the Assyrian astronomers in the 14th century BC.
Yeah, now I have to contain myself from talking about Assyrians because that's all I do on Fan of History. But that's very early for the Assyrians. So good work, Assyria.
Yeah, let that sink in. 14th century BC. They're just learning to write.
They've had writing for quite some time, but it's very early for astronomy in Assyria.
Yes, true.
The Babylonians are usually way ahead of the Assyrians in astronomy.
Okay, so some neat things about our great planet of Mercury. And we're not talking about liquid metal, even though it's very close to being liquid metal in the spots. It has zero atmosphere, for the most part.
Yeah, you often hear talk about an atmosphere, but that's not an atmosphere in any sense we would recognize. There's a couple of particles hanging around.
Yeah, see, the solar winds, what they do, and the solar winds come off of the sun, like, and what they do is they kind of replenish an atmosphere around Mercury, but it's pretty much all radioactive decay and dust.
Yeah.
So that's not exactly an atmosphere, but that's the closest thing to an atmosphere it has.
And that gives you a clue to Mercury's origin, because Mercury is kind of a planet core. It's sort of, stuff is missing on Mercury. The planet core is enormous, and there's not much else left of Mercury. So you could easily think that Mercury used to be a bigger planet. And one of the hypotheses why Mercury is just a core is that the solar wind has just ripped it apart, sort of removed particle per particle. So in the end, only the core remains. And that's kind of what's happening every day with this atmosphere, as you might call it.
Atmosphere.
Stuff gets blown off. Another hypothesis is that something crashed into Mercury. Mercury's orbit is really strange compared to anything else among the planets, because it approaches the sun much closer on one side and much farther away from the other side. We said 0.38 AU, but it varies between 0.35 and 45.
Yes.
So the orbit is definitely not a circle. And that could be due to a collision. So maybe something similar to what happened to the Earth, but on a smaller scale.
Very, very possible. Okay, so the next topic here is, obviously we're talking about how close it is to the sun. This thing can be extremely hot and extremely cold.
That's interesting, isn't it?
Yeah.
So your day would be very, you would have to dress for the occasion.
About 800 degrees Fahrenheit. You would need a mop suit.
Yep.
And probably other things on top of that. But at nighttime, we're talking very, very close to absolute zero.
Yeah, because there is no atmosphere holding. I guess we're pretty far from absolute zero, but it's still much colder than anything on Earth.
Minus 280 degrees Fahrenheit is pretty damn close.
That's cold, but it's not like outer space.
True. Here's one of the strange things, though. Even though it is the first planet, the closest one to the sun,
yeah,
it's only the second hottest.
Yeah, because stuff has gone bad on Venus.
Oh, yes, Venus. The topic of our next show. So Venus is actually the hottest planet. This is only the second hottest planet. And somehow, Dan, you want to take this part? Because this, I mean, even though I've seen the pictures, it still makes zero sense to me.
Yeah, the second probe that reached Mercury, a messenger, discovered the ice that was hypothesized. So on the poles, you have water ice on Mercury. And the poles are pretty interesting because they never get direct sunlight. So they are in the borderland between night and day. And Mercury is not gravitationally locked as the moon. It's locked in a 3-2 gravitational lock, which means that it actually rotates and every spot on Mercury gets sun except the poles.
Right.
And I've heard different things here in my sources about the temperature at the poles. One of the sources had the temperature at the poles at about freezing. And that sounded too good to be true. So you could actually have liquid water on the poles.
Yeah, at certain times. See, the funny thing with the water, and see, it has nothing to do with temperature to me, is why I find it just absolutely amazing that there's ice there. It's the solar winds.
Yeah.
How is that not ripped it all away?
Protected. Yeah, you are protected from them at the poles.
It's just so odd to me. You know, you would think that, I guess it is mostly metal, so it does have a magnetosphere.
Yeah, but it's small. It's, I think it's 1% of the Earth's
right.
Strength.
And around the Earth, the poles is actually, okay, our actual solar poles, not our North Pole and our South Pole.
Yeah.
That's where, it is the worst as far as radiation getting into the Earth because it's just how magnetism works. Go look at a chart of magnetism, you'll see, oh wait, right here, our magnetic poles is where, sun radiation does leak in. That's why I find it so weird that somehow there's ice there. But there's ice there.
Yeah, and it kind of has to do with the very small tilt of Mercury that compared to the Earth, the Mercury stands just upright and there's no tilt.
Yep.
And that means that the poles are actually protected by rock, pretty much. That Mercury shields its poles. So if you want to go to Mercury, you should go to the poles.
Yes. And when he says small tilt, we mean like 1/30th of a degree.
That's a very small tilt.
That's a very small tilt. Like you're not going to notice that by eye.
No, it's perfectly straight up.
Mm-hmm.
Which is very different from other planets, as we shall see in this series.
Well, just Earth alone, which we've already kind of talked about. Earth, yes. I mean, it travels a distance. We have summer and winter because of our tilt.
Yep.
So this thing is just, I mean, it's equator, bang, facing the sun all the time. It is just straight as an arrow, which is
horrible seasons or no seasons rather on Mercury.
No, where you're at is the way it's going to be. There are no seasons on Mercury whatsoever. There's also nothing of something else on Mercury.
Moons. No moons.
Not any sort of type of moon whatsoever has ever been discovered.
And I think it's impossible that the sun is too close, so Mercury can't hold on to a moon because the sun will just steal it. Hey, that's my moon.
Yeah, I wonder about the really tiny things that could be considered a moon. You know, like slightly bigger than space dust.
Yeah, I think the sun steals those things too, but I'm not 100% sure.
Well, I think the winds would blow them away, to be honest.
Yeah, either the sun steals it or blows it away. Like, Mercury, you can't have a moon.
Yeah.
We talked about this, Mercury.
No fun for you. You don't get to have friends. Now get in your
You
room.
just get blasted, Mercury.
Sit in your corner, get in your room, and shut up. We're running things here is basically what the sun says to Mercury. It's pretty terrible.
Eat some radiation.
Yeah. I know here in America we got a problem.
What's that?
Obesity. And I found a great way to lose weight. We just go to Mercury.
Wow. How much would you weigh on Mercury?
Well, you would weigh 38% of what you do on Earth.
Nice dodging of my question about your weight.
I'm not doing that math. I'm tired, remember?
Yeah, this is also exactly the same, almost exactly the same gravity as Mars.
Yep. So it's weird. Now, when I say weight, that's actual weight. That's because of how much less gravity it is. You're still not losing any mass. So
Exactly.
You're still going to have to figure out something to do with all of that. But it won't weigh as much. Your knees will be healthy longer.
That means that if we figure out how to operate under Mars gravity, we have automatically figured out how to operate under Mercury gravity.
Oh, damn.
Yeah, that could be useful in the future.
Mind blown. Boom.
Okay, let's talk about day and night and years, because they are different on Mercury.
Yeah, different from what we think. We think, oh, a day is shorter than a year. No.
No way.
That's not how that works. One day on Mercury lasts about 176 Earth days.
That's crazy.
It doesn't spin real fast. We already talked about its strange lock, 2-3 lock, but a year on Mercury is only 88 days.
I imagine that you're enjoying the sunny day on Mercury, the water is boiling, stuff is melting, and then evening comes after many, many days, and then it gets absolutely cold and horrible.
That's their seasons.
Yeah, but it's a day.
That's it. It's just wow.
And the year is half as long.
Right. It's just so weird when you think about it in general, because it does kind of scoff at conventional wisdom, because you do think about years as a year's longer than a day. An eon is longer than a year, so on and so forth. And just to have any of those flipped, it changes everything you was taught from the second grade up.
We have 2 years in a day on Mercury.
Yeah, kind of crazy. So now what I want to talk about is one of the things I think is really cool, because some believe that the core has not yet fully cooled. And the core is 42% of this planet. And when Dan over there says that, it's mostly core, you're not going to find 42% on any other planet. But the planet has these things called lobate scarps.
Sounds like a venereal disease.
It does sound like a venereal disease. Yeah, very much so. But these are wrinkles, so maybe it is a venereal disease.
Oh no, Mercury, what have you done?
So it's on the surface of the planet itself, these wrinkles. There's no other way of explaining it. They are wrinkles. And they think it's from the iron core cooling and contracting in certain spots, which just has caused the outer crust and mantle to just wrinkle up.
Strange.
Yeah, not what you would expect, not what we're used to. Huh. Come on, man. You gotta bring me some cool stats here, bro.
All right. We have, Mercury is the most cratered planet because there are no plate tectonics, there is no volcanic activity, no natural geological process to heal the planet. So the surface is super old, just like the moon. Mercury is pretty similar to the moon, except the fact that it's so heavy. It's somewhat similar in size to the moon, volume-wise.
Yep.
And it looks like the moon.
Except for the scarps.
Yeah, the moon is too small, too light to have scarps.
Yeah.
So the moon is safe from the lobate scarps.
Darn.
We also have a lot of craters then, and if a crater gets bigger than how big?
250 kilometers.
That's a pretty big crater. That's a bad day of Mercury when that thing hits.
Yep.
When it gets bigger than that, you call it a basin. And the biggest one is the Caloris Basin at 1,550 kilometers.
Okay, so let me just go back and say that the diameter of this planet alone is only 4,880 kilometers.
So you see this basin.
It's a little over a quarter of the planet.
Yeah, that's a pretty big hit.
And it's sizable.
If I remember correctly, there is a mountain on the other side of Mercury from the Caloris Basin. So one hypothesis is that it was hit so hard that the surface on the other side of the planet sort of bulged out.
Yeah, it just kind of rose up, kind of like our plate tectonics do here, where one mass meets another mass and it gets forced up. They think that that's how it got hit.
Yeah, bad hit.
Very, very, very not good.
So let's talk about the probes.
Like alien probes?
Yeah, aliens from Earth that we have tried to explore Mercury. But exploring Mercury is hard. When you start a project, you're building a probe, you get some money from NASA, or you want to go space exploring, then you're thinking about, there's Mars. Mars is nice. Mars is easy to explore. Let's go there. Or if you really want to challenge yourself, then, let's go to Venus. But then going to Mercury is like this boring rock closest to the sun. It's hot. It's really hard to sort of steer your probe so the sun doesn't do strange things to it. And even if you manage to do that, then the probe gets burned. But we did send the Mariner 10 probe in 1974. And it just did a flyby or a couple of flybys of Mercury.
It managed 3 complete orbits. That's pretty good.
Wow, 3 orbits. Orbiting is super hard.
That might be the closest thing to a moon this planet's had in a long time.
Probably. But we did only get pictures of half of Mercury. So for the longest time, we only knew how half of Mercury looked.
I think that's pretty good. We got half of the planet in 3 orbits.
Yeah, and that's
I was impressed by
a lot of other things in the solar system.
Yeah, I was impressed by that. He was like, just half. I'm like, wait a second, that's actually pretty impressive.
Yeah, this is what we grew up with. We only knew half of Mercury.
Yep.
But then in 2004, the Messenger probe was launched, and it managed to check out the entire planet. And it was busy for quite a while. It also discovered the ice, which was amazing.
Yes.
But we still have questions. Compare this to Mars and Venus. There's been plenty of probes sent to these places. So now we are sending the 3rd probe. And for once, these things were all sent by the US Messenger and Mariner. But now the European Space Agency, in cooperation with Japan, is sending a little thing called Bepi-Colombo. And Bepi-Colombo is actually 2 probes. So one of the probes its mission is to map the planet and get even better resolution pictures of Mercury. And the other one its only mission is to study the magnetosphere of Mercury. It is weak, but it is a magnetosphere, and that's interesting, because that proves then that the core is not dead, like it is on Mars. This thing hasn't been launched yet. It's supposed to launch in 2018, and it will reach Mercury in 2024. So maybe we'll be around to talk about Bepi-Colombo when it gets there.
Have you ever watched Columbo?
Yes, I have.
That's all I can think of every time you say it is just this short guy with a cigar and a trench coat.
Orbiting Mercury.
Yeah, just...
Mapping with a pen and paper. Very interesting.
It's just, I'm sorry, my mind wanders sometimes, but every time I hear the name Columbo, that's all I can think of.
And now we have really exhausted the subject of Mercury, but I have one more thing.
Well, that shows just how little is actually known. Although we went over a lot there.
Yeah.
There was a lot that we actually did kind of go over, but at the same time, there really wasn't much. Because we ripped through it in about 15, 20 minutes.
I hate to be negative, but this is by far the most boring of the 9 planets in the solar system.
But I think it's actually so cool. Don't get me wrong. The other ones all have their neat quirks, But this one has its own neat quirks in its own way because there's a lot of stuff going on there that we don't see elsewhere.
That's true.
You know, like the tilt. That's something that just boom. Wow, how's that happen? You know, considering there are people who actually believe that this planet got hit, yet it still holds a tilt that's perfect.
That's strange.
You know what I mean? Even with the fact that it's been hit by meteors that leave basins a quarter of the size of the planet, and yet it doesn't knock the planet off of that perfect axis. You have to wonder, is there some role that the sun's playing in keeping it so perfectly locked?
Yeah, you would think that.
I'm sorry.
This is really an abused planet by the sun. But I can make it a little more interesting before we leave it.
Okay, game on. Prove yourself.
We have these poles, especially the North Pole, where temperature is fairly stable. You avoid getting blasted by the sun. So there's actually been some studying on, could we colonize Mercury? Could humans actually live on Mercury? And there are several reasons why you would want to go to Mercury. Of course, you have this enormous supply of metals on Mercury. As it is this blasted planet core, it's so metal rich.
Okay.
And you also could use solar panels very efficiently on Mercury because you get about 4.5 times as much energy from a solar panel as you get on Earth.
Okay.
You could hide out at the pole, hidden from the sun. You have water, and you could just stick up a solar panel and you have all the energy you'll ever need from that panel.
All right. I'm going to shoot all this down when you get done.
There are even wilder plans where you would have moving platforms on the surface of Mercury that would sort of constantly be in the twilight zone, much like we talked about on Proxima Centauri B. That there you were if it was gravitationally locked, you could stay in the twilight zone easily. But on Mercury, you would have to move as Mercury actually rotates. So that's a bit wilder. I think hiding out at the North Pole is the plan. And then you have these synergies with Mars exploration that if you can survive the gravitation on Mars, you can survive the gravitation on Mercury. Okay, shoot me down.
Okay, so first off, I'm trying to think here. So what we have to do is we have to move at a rate of back of the envelope math here, so don't hold me to this. It takes 176 Earth days, and it is 4.880 kilometers. You probably, to stay in the twilight zone, to be realistic, you'd probably only have to move about 30 miles an hour.
Yeah, it's not that fast.
Yeah, I mean, that's actually kind of doable.
Yeah, you probably have to build a road because hitting a crater will slow you down.
Hitting a basin will slow you down even more.
Yeah.
But you know what I'm saying? You're not moving that quickly. It's something that, with archaic means, we could pull that off. A horse can do that. It just can't keep it going forever, right?
Send horses to Mercury.
Yeah.
Plan 1A. Bring plenty of horses.
And then bring more. Because they're going to hang out at the North Pole because there's water there. Maybe.
Build a stable at the North Pole.
Yes. See, I think our best bet with that would be to probably biodome, sort of.
Yes.
The North Pole. That way we can increase the temperature inside to turn the ice to a liquid water and sustain ourselves off of that water. Food source would be rough regardless of how you put it, because I'm sure that the soil there is not compatible with growing since there really isn't any real soil left.
No, you have to make do somehow.
Right. And, that's why you have the horse stable. So you can,
exactly.
That way you can corral the stable of cows that you bring as well, who feed themselves on fake grass.
So all you need is a fleet of spaceships that constantly bring new horses and cows.
And hay. Lots of hay.
Lots of hay. That's probably very expensive to send to Mercury.
Probably. Let's see. Every time they send something into orbit currently, it's like $10 million just to get it off of the planet.
Yeah, space elevators will take care of that on Earth.
Maybe.
I'm hopeful.
I'm hopeful, but I'm not 100% sold on that technology quite yet.
It's, of course, a much better idea to colonize Mercury than to try to colonize Venus. And we'll talk about that next time.
True. So, here's the problem.
Venus is hell. Okay, go ahead.
Okay, so say we do everything good there that we just talked about, bring the horses, bring the cows, put the dome on the North Pole and everything else.
Yes.
The sun is growing.
Yeah, but that's a long-term problem.
It's a long term for us to colonize it.
Yeah, but we could still, if we really put our effort into it, I think we could colonize it in like 200-300 years, and then we'd have a couple of tens of millions of years being happy on Mercury.
Possibly. Okay. And two, I think when we start looking for possible places to colonize,
Yes.
we should probably look away from the sun.
Yes.
Because we know what's going to happen.
Yes.
In billion years?
Yeah.
Yeah. You don't want to be closer to the sun.
But think of the mechanics of free market. So when Mars is colonized and this technology exists, somebody will go to Mercury to colonize that just because it isn't taken yet.
Well, the fact that you're already in Mercury, or you're already on Mars,
Yep.
I think they push further out to the asteroid belt where you can find even more, maybe not, in quite the quantities, but you can get a more diverse types of metals and stuff from the asteroid belt than you could from Mercury. You're going to get a lot of iron from Mercury.
Yeah. And of course, Mercury is not probably among the top 5 targets for colonization in the solar system.
Which is probably good.
Yeah. But it is theoretically possible.
Theoretically possible, interesting enough to bring up, but I don't think it's a great idea.
No, let's leave this poor blasted rock now.
Yeah.
And continue.
So are you going to sign up for the SpaceX mission to Mercury?
Interesting. I would love to go to Mars, but if Mercury is all that is offered, maybe I'll go.
Yeah, I'm not going to either.
I'm going to Mars if I get the offer.
Look, I'm not doing that until they figure out how to bring me back. I want that option.
You're so picky. That's like, let's just go there and see what happens.
Yeah, let's not. Let's figure out how to get back. I don't buy the first generation of iPhones. Work out the bugs, then let me know about it.
Yeah, Mars colonization will have a couple of bugs. We should probably spend the whole episode talking about colonization of Mars when we're done with the solar system series, because colonization of Mars is a super interesting subject.
Yeah, we'll probably go over colonization of outer planets just in general, because there's a lot there when you talk about like terraforming and things like that. So I'm sure we'll do a whole episode on that. Maybe not just Mars, but just in general at some point. We're going to take a fairly quick break. You won't even notice it because the magic of editing. So listen to this quick commercial and we'll be right back.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
All right, astronomy fans, we have sad news this episode. And once in a blue moon, we're going to talk about the people who did things for the betterment of science and space in general. And unfortunately, a lot of these people are beginning to pass away. And on December 8th, 2016, John Herschel Glenn Jr. died. John Glenn. He was an American hero, to be honest. And that comes from an era when the USA was legitimately considered a true beacon of freedom. I know we aren't now, and I wouldn't stake that claim to save my life. But at that time, 50s, 60s, yeah, we was. So gotta give the man credit where credit's due there. Before he became an astronaut, he was a fighter pilot, born in Ohio, and he fought in World War II and the Korean War. That's the United States versus Korea. I don't know what other countries call it. That's what we call it here.
It's called the Korean War.
Okay, fair enough. He earned 18 clusters of air medals.
Wow.
So when you look at, you see the pictures in the movies of the guys wearing the suit, they're dressed blues and they have like the ribbons and stuff. A cluster is like 3 of those ribbons.
Okay, so we're talking over 50 medals.
No, It's weird. Yeah, okay, in a way. Sure, we'll go with that. He also earned 6 Distinguished Flying Crosses. Now, these aren't just given away. These are like a big deal.
So the guy knew how to fly an airplane.
Not only fly an airplane, but he knew how to fight while doing it.
Wow.
You know, this is back in the days of like the Red Baron and things like that, where you was flying an airplane and shooting a gun at the same time. And you had to take down more than one other plane to earn a Distinguished Flying Cross.
Jesus.
Yeah. Badass. Great hand-eye coordination. You can see it right there. This is one of the reasons he was chosen as one of the Mercury 7. These were 7 test pilots that the United States chose to become their first astronauts.
And they were all test pilots, right? They really went for good pilots.
At that point, they were all basically test pilots. I mean, they were all former military pilots, but at this point, they had all become test pilots as well. And this was during an era of avionics expansion where people were trying crap out that just didn't make sense. And, test pilots were dying, but you needed the best pilots in the world to test these new planes. Like they were going from propeller to jet. That should say a lot right there.
Oh, yes.
But here's the big thing about Glenn that really, kind of sets him apart from other astronauts is, one, he was only the 5th person to ever be in outer space. 5.
Wow.
But he was the first American to orbit the Earth.
What an amazing thing. Imagine the feeling like, wow, I'm orbiting and nobody has done this before.
No American. There had been one Russian cosmonaut who did it before him.
Gagarin, right?
I believe so. Yeah.
No.
But he was the first American to do this, and he made it back to Earth and everything else. Then in 1978, he received the Congressional Space Medal of Honor.
Was that the first Space Medal of Honor?
I don't know if it was the first, but it was awful close to it. We have a thing in the United States called the Medal of Honor. It's given away by the President of the United States, and each president may give out 2 of those during his entire 8-year term.
Really?
Yeah.
So if you're only in for 4 years, can you only give away 1?
No, you can give away more than that if you want, but it's such a distinguished honor that you do not give it away lightly.
Okay.
And the fact that they gave this man one of the medals of honor, and usually what you need to do to get a medal of honor is you need to jump on a grenade.
Yeah.
And save 50 other soldiers. That's how you get a medal of honor, and he got, the space equivalent of that.
And given the risks he took as a test pilot here, I think he pretty much jumped on a grenade to save others.
I would say so as well. I mean, that's basically what he did, and he earned it. He also became a United States Senator in 1974 for the state of Ohio, and he held that seat until 1999.
25 years.
Yeah, but, he did something else in there. In 1998, while still a senator, at the ripe young age of 77 years of age, he decided he was going back into space.
Whoa.
That is the oldest man ever to go into space. So just think, when you wake up in the morning, you're hitting your 40s and you're like, oh, my back hurts. Yeah, this dude said, screw that, I'm going into outer space. 90% of the people I know on this planet is a coward compared to this man, and I'll include myself in that.
Yeah.
I mean, this dude had cojones. The size of watermelons. He's the only person to fly in 2 of the United States, of NASA's, not the United States at this point. NASA is actually not a government office anymore. But he was the only person to fly in the 2 most successful space shuttle programs for NASA, and that was Mercury and Discovery.
Oof.
Nobody else has done that, and that's because he went back into space at 77 years of age.
Yeah, the other astronauts decided that we better stay down here.
Yeah, it was like, you know what? I'm old. I don't need to go back up there. And he was like, yeah, screw that. I'm going. There's just so much respect I have for that. I know 77-year-old men who legitimately can't wipe their own ass. Like they're just.
That's harder to do in space.
They're just completely incontinent. Their brain doesn't work anymore, and this dude's going into space. It just blows my mind. He then received the Presidential Medal of Freedom in 2012, and that, of course, in 2012 would have been given to him by President Barack Obama.
It's of course really sad that he has passed away, but what a full life to get to 95, to go to space at 77, and to have accomplished all of this, I think, that's a good life.
Yeah, and this is only a small portion of what he did. These are the highlights that I found. I didn't even talk about the fact that he loved his wife, like to a point that any person who saw it would just respect it. His wife had a speech impediment.
Okay.
And he was super protective of that. And if you was like a reporter and you brought that up, he wouldn't talk to you any. His wife was off limits. You left her alone. And it was, it was a true type of, I just love this woman too much. I don't want to see you people writing anything bad about her. If you have any attacks, bring them at me. That's very respectable.
Come with me on the space shuttle and we'll talk about this.
Right? Yeah. Come to space with me. I'll deal with you up there where nobody can hear you scream. And there's so much other things that I could say about this man, but I just can't say it all because he lived an amazing life.
Who is still around of the famous astronauts?
We still have Buzz.
Yeah.
Buzz Aldrin has yet to die. He was one of the guys that landed on the moon. I'm not sure if Neil Armstrong is still around, but yeah.
I'm doing research with Google as we speak. Is Neil Armstrong alive? No, he died in 2012.
Okay. Yeah, it sounds about right, actually, now that you bring it up. So, there's not many of the great astronauts, or even the cosmonauts, to be completely honest, who paved the way for, our current spaceflight technologies. Now we don't even think about sending people into space unless they're going to the space shuttle. We don't.
To the International Space Station.
Yeah, the space station, I'm sorry. Unless we're sending them to the space station, we don't send people into space. It's too expensive, and to be quite honest, it's a lot easier just to send a robot.
Yeah, we had our first Swedish astronaut going to the International Space Station a couple of years back. And today I actually read this morning that our second astronaut is a candidate for going back to the moon.
Yeah, there's a few countries that want to go to the moon now, and
yes.
I think it's cool. I don't think there's not stuff that we can't still discover on the moon. There's something.
I think it's a shame that we haven't been to the moon for such a long time, but I guess the moon is fairly boring.
It really is, but at the same time, there's something to be said about getting, eyes on. It's one thing to send a robot. You're going to get a lot of the data that you need, but there's something about eyes on. Human eyes, human hands, feeling, touching, looking at it and making an analysis on the spot on it instead of, sending it through a machine and going through all that. There's something to be said about, human interaction with it that really makes it feel like more of a discovery. There were scientists for years who believed the Earth was round and thought that, hey, maybe there might be land that we're not at yet. The Europeans, there were some European scientists who believed that. But until we actually got Europeans, bang, on, what's currently known as North and South America.
Oh, yes.
It didn't matter what the scientists said. For most people, it wasn't there. So you got to get hands on sometimes. There's a lot of famous quotes about John Glenn, and we're going to end the show with one of them, as bad as I don't want to do it. But before we do that, we have to let you guys know that if you become a patron, we will thank you. Your name will be said on the air unless you don't want it to be. You can send us a message saying, please don't say my name on the air, and we won't. I think that's fair.
You actually get to choose when you become a patron if you want the rewards or not. If you say that you don't want the rewards, then we will not say your name.
Yeah, so very simple. Please, like I said, next week we're going to go over Venus. Please shoot us your emails. Email us some questions. We want to interact more with you guys who are listening to us, so please shoot us those emails at aofcast@gmail.com, and we'll answer any questions you have about Venus. And trust me, there's a lot of strange things going on Venus, and I know that we're going to try to go over it all, but your questions will help us. If you wanted to get a hold of me directly, you can find me at FOA Angelo on Twitter. I am on there. I haven't been tweeting much lately because this is the busy season for work, but I will be more in the near future. You can like our Facebook page at facebook.com/fan of astronomy, and you can find Dan where?
At Dan Horning on Twitter. And you can also find me on Facebook at Dan Hörning. So you have to put 2 small dots over the O.
And you can find him on umpteenth other podcasts.
Oh, yes. I think after New Year, I am going to be doing 9 podcasts at the same time.
You know what? I know how you do it. You don't do the editing.
No, don't tell them my secret.
I'm pretty sure everyone knows I edit this. Okay, so I was trying to figure out how we was going to end this show. You know, we have our normal kind of sort of ending that we do, but with John Glenn passing, I felt like we had to pull one of his quotes, and I knew it was going to be cliche to go with it, but at the same time, it's the best way. So from Dan and myself, Godspeed, John Glenn.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out. Throw them a couple bucks an episode. They will really appreciate it. Thanks.